On August 28, 2009, former CERN physicist Christer Fuglesang from Sweden lifted off aboard Space Shuttle Discovery on his second mission to the International Space Station. The main purpose of STS-128 was to equip the space station with more research facilities to put to use inside the Japanese, European and American laboratories. In Christer's personal flying kit, Item 55, a symbolic soft toy, stood out. Christer brought it back to CERN 2 years after return to Earth.
The CERN ESA neutralino here really enjoyed the ride to space as much as I did, I think. It's now, more than 2.5 years ago. We went together on the shuttle Discovery. The mission was called STS-128, International Space Station. We brought up a lot of new experiments to the space station, plus food and logistics, spare parts.
At the colloquium he gave at CERN on May 24, Fuglesang presented the physics research program carried out on the International Space Station. True to his background as an experimental physicist, Christer still finds CERN exciting, even compared to the thrill of 2 space flights and research in zero-G.
My background, I'm a particle physicist. I worked at CERN, and the science in particle physics is maybe the most exciting science, and it's very close to the fundamental science of the universe. How the universe evolved, and you need to know one to understand the other.
After the termination of the Space Shuttle program a year ago, Christer was appointed Head of Science and Applications of the European Space Agency Human Space Program.
In practice, that means that my division, we select experiments to be sent to the space station. We work with the scientists to make sure that it's an experiment which can be done well in space, and then other people implement the experiment, but we are the prime contact to the scientists. And in addition to experiments on ISS, you do experiments where in microgravity shorter terms. For example, you can fly in aircrafts, goes in parabolas, and you get 20 seconds each time in there, and that's enough for some science. Other science we're doing is we're looking into what is needed to prepare humans for long duration flights to Mars, etc., exploration. And one of the very important areas is radiation. There's a lot of radiation out in space. And really when you go beyond the space station, you go outside the radiation field around the Earth, is much less protected. You need to know that. And that is close to the science being done here also. So glad of the idea which came up to send a neutralino to space, because it really ties together what we do in ESA. We do research in space, we look into space, what can be found there, and one of the things we're looking for is the dark matter. But neutralino is also what is hunted for in LHC. So the race is on, who will find it first?